Hello, sir.
Sir, your mic is mute, sir.
Sir, has not started.
Actually, you have to tell me. No, I have explained a lot of things. Okay, so somebody has to tell. No, okay, let it be. Once again, I'll explain. Okay, let it be. Did you heard something or not? Nothing. Nothing you heard. No.
No, sir.
No, sir. Since
Nothing, sir.
starting, you haven't started.
Okay. 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 Yesterday we have seen some performance parameters like rolling resistance, aerodynamic forces. We have considered drag forces, lift forces. Okay, and as well as we have seen the gradability of an vehicle, and in the rolling resistance, that is very important other part of vehicle. Okay, you can see, tires are made up of what we know that those are made up of elastomer. Okay, that is a property of viscoelasticity. So viscoelasticity is nothing but so for viscous we are going to take it as a damper. For elasticity we are consider it as a spring. So whenever we are modeling any car model, so that we consider it as, so because of these two properties we will consider mass, spring as well as damper. So this is the one reason, so that we will consider, and we are going to do going to do the model of vehicle. So yesterday already we have seen the which are the forces are acting on the vehicle. Okay, so just I have drawn with my own diagram. Okay, so I have took my own parameters to so there are, yesterday I have shown you one figure, but he has taken some other parameters. I have took it from GMI, Reza and Zazar books. That this figure it has been indicated over there. Okay, so which are the forces are acting over here? So first force is acting RA, that is a aerodynamic force. So at a height of HA it is acting. Okay, at a height of HA it is acting. So I have considered a term as a RA, as a aerodynamic force. And two forces are acting in the direction of motion of vehicle, uh, FF and FR. FF is considered as a traction force at a front tire, and FR is considered as a traction force at a rear tire. Traction force depends on what is the type of vehicle, whether it is a front wheel drive, whether it is a rear wheel drive. It depends. Okay, whether it is acting on the front tire with sometime it is acting on the rear tire when it is rear wheel drive. So on either also it can act, FF and FR. That is a traction force. RA is a aerodynamic force, and two forces are acting, which are the R. So R can be considered as a rolling resistance. Okay, that is RRF. So RRF is a rolling resistance for front tire. RRR is a rolling resistance for, this is acting in this opposite direction. Okay, so traction force is acting in this direction, and the rolling resistance is acting in this direction. Rolling resistance depends on the contact patch of the tire. Whenever the load is acting on the tire, so it deforms the tire. Okay, so as I said, loading and unloading parameter yesterday. So uh, yesterday we have seen some equations also on that rolling resistance. That is an plays a crucial role in the performance of the vehicle. Okay, so rolling resistance can be written as a RR also. RR is a combination of both RRF and RRR. So which has been shown over here in this figure, RRF and RRR. Okay, so how many forces we have seen? Aerodynamic force, which is situated at a height of HA. HA is nothing but your aerodynamic height. And second thing is a traction force, which is acting in the motion of vehicle, in which direction it is moving, in that particular direction traction force is acting. And next is the rolling resistance, which is acting opposite to that, so which will be helpful in the braking also. Braking maybe rolling resistance हेल्पफुल करता है गाड़ी को डिसेलरेट करने के लिए, एक्सेलरेशन होता है उसको डिसेलरेट करने में रोलिंग रेजिस्टेंस प्लेज अ वेरी इंपॉर्टेंट रोल व्हेन वी आर अप्लाई अ ब्रेक to the vehicle. Okay, so two reaction forces are acting, that is, one is a WF. WF is reaction force is acting in the front tire, and WR is a reaction force acting at the rear tire. Okay, rear tire. So that our main aim is that we are going to find out WF for the front tire and WR for the rear tire. If you get WF, then very easy to get WR. There is no big thing. Only the sign changes will be there, and length. So if you are going to find out the equation of motion or equations for a dynamic equation of a vehicle, so you need you required dimensions of the vehicle. So dimensions of the vehicle over here has been provided. So front of the tire to the center of gravity, CG of the vehicle is L1, and CG of the vehicle to the rear tire which consider it as a L2. So overall length will be L. Okay, overall length will be L. Okay, so one more weight is acting over here at the center. So this force can be resolved into two. So one is of a W sine theta and W cos theta, W sine theta and W cos theta. So whenever the vehicle is moving uphill, so it creates an angle of theta s over here. Okay, this angle theta s is equal to this angle theta, okay, s. Okay, so you can consider it as a theta, or you can consider it as a theta s also, depends on you how the parameter you are going to consider, that is depends. Okay, so this force is acting in this direction, W sine theta and W cos theta. So one more force is acting, F is equal to ma. If you see in any of the subject, we are well known with the F is equal to ma. So basically whenever we are writing the equation of motion, equations for any vehicle, so we consider the D'Alembert's force. Okay, that is pseudo force we call it as. It is not a good practice to write this D'Alembert's force, but we need to write down as we are taking the moments. So for that we are going to take instead of ma, W by G into A, we have to write down as a D'Alembert's force, which is acting in the opposite direction. Okay, so one more force is acting in this downward direction. What is that force? That is called as a drop or pull force. Okay, so drop or pull force when comes into picture, okay, whenever we attach a trailer to the vehicle, okay, trailer to the vehicle, so this is situated at a height of HD. Okay, that is drop or pull height. So you can see over here, this is a drop or pull height. So we have it is situated at a height of HD, and center of gravity, which is situated from the ground, it is situated at a height of H. So if you consider all these heights are equal, okay, all these heights are equal, so that's why we can consider, assume HA is equal to H is equal to HD. Okay, HA is equal to H is equal to HD. Anyhow, we are not considering the drawer pull over here, so we can neglect. Okay, we can neglect. So neglect this drawer pull force. Whenever you add the trailer, so you can consider this force also. Okay, this force can be considered whenever we are attaching a drawer pull. So over here, some of the assumptions we need to take. So assumptions such as cos theta is we are considering the value of cos theta is very small. It is negligible. Then cos theta we are considering as a 1. So R, as I earlier explained, R is nothing but rolling resistance, can be written as rolling resistance coefficient, that is FR into W. So wherever R R will comes, we can replace with the help of FR into W. So we know that F is equal to MA. So F, we are going to write down the all the forces acting on the vehicle. Okay, so MA is equal to like so forces are acting in X direction. Okay, so these are acting in this direction. Okay, if we are considering it as a X direction or in this direction, so two forces are acting. One is a FF, so that is considered as a positive. Okay, so if it is the opposite force is acting, we consider it as a negative sign. Sign conventions are very important over here. So FF plus FR. Okay, FF is for the front tractive force, FR is for the rear tractive force. Okay, so these are the two forces. FF plus FR can be written as a total force F. Okay, total force of the vehicle can be written as a F, also can be written over here. FF plus FR दोनों मिला के हम लोग F भी लिख सकते हैं. ठीक है, तो minus one more force is acting over here in the opposite direction can be written in the negative sign. So that is RA, that is aerodynamic force. Okay, aerodynamic force can be written minus of RA and then minus RR. Okay, so this two forces RRF and RR can be written as a minus RR. So combination of front rolling resistance and rear rolling resistance. RR is nothing but a rolling resistance of the tire. Okay, so here I have indicated that forces are acting in the X direction, so we are considering the equation according to that. Okay, and minus this force we need to take also minus W sine theta S, also you can write down theta also. It depends on you how you can take. Okay, so this is the resistance due to gravitational force. Okay, this is resistance due to gravitational force W sine theta S. Okay, this also can be written as a RG also. In short form RG भी लिख सकते हैं, तो RG भी लिख सकते हैं और W sine theta S भी लिख सकते हैं. So this is the first equation. So MA is equal to FF plus FR minus RA minus RR minus W sine theta S or RG. So if you wanted to add one more force over here, so that is FD. So FD can be written over here minus of FD. Okay, this is acting in this direction. Then the negative sign we have to consider over here. So that is negative sign over here, negative of FD. FD can be written over here. That can be neglected because we are not considering the trailer over here. Okay, this is so where FFFR is a traction force, R is a aerodynamic force, R is a rolling resistance, WS sine theta, S is a resistance due to gravitational force. Okay, so over here we are assuming HA is equal to H is equal to HD. So these are the three heights are almost are the same. That's why it is equal. Wherever it comes directly, we can write it down as a center of gravity, H. So then our main aim is to find out what WF and WR. So reaction force at a front tire and reaction force at a rear tire. You can see this is the moment. Take the moment about A. Okay, so we have to take the moment about A over here, this tire. So total, sorry. So WF, so this is WF into L. Okay, WF into L plus, so whatever the things, the moments are there in the clockwise direction, that can be considered as a positive, and which are the forces which are acting in the anti-clockwise direction, which are considered as a negative. So first is the WF into L. Okay, WF into L is what? So over here, this is WF, and this is a total length of the tire. Okay, plus RA. Okay, this is also acting in the clockwise direction. RA into H. So RA is this one and multiply by H over here. So H or HA, or you can consider it as a HA also. You can consider it as a H also. RA into H. So next force is acting over here. That is W sine theta multiply by H. Okay, W sine theta multiply by this is also acting is it is in a clockwise direction, and one more force is acting, that is D'Alembert's force, W by G into A multiplied by what? H. Okay, this is also acting in the clockwise direction. One more force is acting in the downward direction, that is W cos theta, W cos theta into L2. Okay, this is L2, W cos theta into L2. Okay, so this is acting in the anti-clockwise direction. That's why the sign is considered over is here is a negative. Okay, so you can see the sign, you can direction, you can see this is the anti-clockwise, this is a clockwise, this is also clockwise, and this is also a clockwise direction. Okay, so cos theta is a very small, theta s is very small. We are consider this is L2. Okay, a little bit of written like that. So this is 1. Okay, and is equal to 0. Okay, so we need to write down the equation for WF over here. Okay, so WF is equal to, we are taking a common, so we are taking L on the other side. Okay, so first we are writing 1 divided by L multiply by negative sign becomes over here positive. I have taken, so W into L2, so this becomes negative, so minus RA into H, this becomes negative. So why I have written this positive or negative sign? Okay, because of that reason I should not be confused that so whether if the vehicle is going in the uphill, we are considering as a negative sign. When the vehicle is going in the uphill, it is considered as a negative. So whenever I written this, and whenever it is going in the downhill, it is positive. Okay, positive or negative, why I have written that? So you can consider the vehicle is going in the uphill as well as in the downhill also. तो नीचे भी आ रहा है और ऊपर भी जा रहा है, इसी वजह से नेगेटिव और पॉजिटिव मैंने यहाँ पे साइन दिया है. ठीक है, then W sin theta S into H as usual I have written, and this becomes negative. Okay, so minus W by G into A into H. So this is the equation for the front reaction force for the front tire. Similarly, you have to take a moment about B. Directly you can write down the equation. So WR is equal to 1 by L. Similarly, so instead of L2 you have to write L1, मतलब उल्टा आ जाएगा. Okay, L1 आ जाएगा, W L1 प्लस RA into H, यहाँ पे खाली साइन चेंजेस हो जाएगा आपका. ठीक है, प्लस RA into H, दिस इज सिमिलर, प्लस और माइनस. सो अपहिल जा रहा है या डाउनहिल जा रहा है, डिपेंड्स. तो अपहिल जा रहा है तो यहाँ पे क्या रहेगा, पॉजिटिव रहेगा. डाउनहिल जा रहा है तो नेगेटिव रहेगा. इन दैट केस रिवर्स साइन रहेगा. साइन कन्वेंशंस आर वेरी इंपॉर्टेंट. थोड़ा भी साइन कन्वेंशन चेंज हो गया तो पूरा आपका व्हीकल का डायरेक्शन ही चेंज हो जाएगा पूरा. Okay, direction will be changed over here. So and plus W by G, plus W by G into A, sorry this one, W by G into A into H, so WR. So when we take a moment about B, so this is the equation. Okay, this is the equation for a rear tire also. Okay, rear tire. So यहाँ पे नेगेटिव साइन है, यहाँ पे पॉजिटिव साइन है, यहाँ पे प्लस और माइनस सेम है, यहाँ पे नेगेटिव साइन है, यहाँ पे पॉजिटिव साइन है. एक ही साइन चेंजेस होगा, प्लस ओनली इट चेंजेस द dimensions from L2 to L1 whenever we come to the rear tire. Okay, this can be rewritten as WF. WF can be rewritten as L2. L2 can be taken outside and multiply by W. WL2 divided by L minus H can be taken outside divided by L, and this can be resolved. Okay, resolved. So this can be written as RA plus or minus. So RA, so this as taken outside. Okay, RA plus or minus W sin theta S into H. Similarly, we have written. Okay, and plus W by G into A into H. Okay, whenever you solve, you resolve this equation, so you will get this equation number 4. Similarly, can be written as for rear tire. Okay, rear tire के लिए भी हम लोग लिख सकते हैं. तो कैसा लिख सकते हैं? Instead of L2, I have written as L1. Just it changes over there and sign will change over here. यहाँ पे जो नेगेटिव बाहर का साइन ही चेंज होगा यहाँ पे, तो ये साइन होगा प्लस होगा इन द केस ऑफ रियर व्हील. ओके, रियर व्हील में वो केस होगा. ओके, तो दैट इज द डिफरेंस. अदर देन दैट the reaction forces at rear wheel tire will be L1 divided by L multiplied by W plus H divided by L. HARA plus or minus W sin theta S plus W by G into A. This will be similar and this will be also similar. When we simplify both the equations, equation 4 and 5, so how it can be written again? So अंदर का RA plus W sin theta plus W by G. So with the reference of this equation, ये equation, when we refer this equation, so what it will be? W by G plus RA plus W sin theta. So this can be written as F. Okay, F can be written. तो F रिटर्न कर दिया तो क्या हो जाएगा, सारा टर्म इधर आ जाएगा. MA कैसे लिख सकते हैं हम लोग? W by G into A. Okay, W by G into डल नंबर फोर्स, in terms of डल नंबर फोर्स लिख सकते हैं W by G into A. ये सब सारे टर्म इधर आ जाएंगे प्लस W sin theta प्लस RA, सभी टाइम RA. So those terms can be replaced with a F. मतलब I'll show you that. Okay, suppose I have written W by G into A at the left hand side and FF plus FR. So these are the two terms are there, FF and FR. I'll write it as F. Okay, and RA minus RA minus RR minus W sin theta. Okay, so W by G into A plus RA can be taken this side. Okay, plus W sin theta is equal to what? F. This is F minus this rolling resistance can be written as FR into W. FR into W. So FR into W. So this can be replaced over here. Okay, in this equation you can see over here I have written F minus FR into W. So whole this equation can be written like this. Okay, so similarly L2 divided by L1 minus H divided by L, F minus FR into W I can resolve. We can simplify this. Okay, so we can simplify for front and rear tire. Okay, similarly you can write it for this also. For rear tire also I have written over here. You can simplify. So note over here. So when we add both the WF and WR, we will get W, that is full vehicle acceleration we will get. So the next step is you have to add both the WF plus WR is equal to W. You will get a full vehicle reaction. So when we add these two equation, okay, दोनों equation add करेंगे तो हमको final vehicle acceleration मिल जाएगा. This is some of the reaction forces, dynamic reaction forces which are acting. Just do it. This one, this step you can do. So ये step आप लोग करो, दोनों को add कर दो. So try to write down the equation with your own by drawing the diagram. So just draw the diagram. So if you consider the vehicle is moving in the flat road, it's very simple equations are there. Just try it for a vehicle is moving in the flat road. Flat road में आपको resolving forces नहीं आएगा flat road में. Okay, only एक force आएगा, W आएगा आपको mg is equal to m. Okay, W force आएगा mg वाला, तो वही आएगा. और दो reaction forces आएंगे, WF WR similar आएंगे and आपका dimensions भी same आएंगे, rolling resistance वगैरह similar आएगा. तो only you will get very simple equations over there in the whenever the vehicle is moving in the flat road. Okay, flat road में जब भी move करते रहता है आपका जो can say what we can say what is the equation we will get. So I'll let you know that what are the equation I'll get. So for WF, I'll get it as a half mg into A2 by L for whenever. So WF is equal to 1 by 2 mg into A2 by L. For WR, I'll get as a half mg A1 by L. So यहाँ पे रिएक्शन फोर्सेस कैसे आएंगे? सो रिएक्शन दो कंसिडर करना पड़ेगा, एक मोमेंट कंसिडर करना पड़ेगा. सो यहाँ पे WF plus WR minus mg, that is W is acting. So force as well as moment we need to consider. Okay. Equation of motion you can write down similarly how we have written now, and you can get these two equations. Very simple. चार लाइन में आ जाएंगे, चार पांच लाइन में equations आ जाएंगे. Bit of difficult this is. That's why I have shown you how to write the equation of motion whenever the vehicle is moving in the uphill direction. Okay. So similar kind of things can be written for the bikes also. आपके बाइक के लिए भी आप लिख सकते हो. Similar kind of reaction forces can be written over here. Okay. So this is how we have to write the reaction forces for the any kind of vehicle. Okay. Not only single vehicle, any kind of vehicle can be written similar kind of reaction forces. So next is a vehicle power plant. Okay. So we know that vehicle when we consider a vehicle power plant, there are two limiting factors to the maximum tractive force of effect of the vehicle is, one is a maximum tractive effort that the tire ground contact can support, and second one is a tractive effort that maximum torque of the power plant can produce with the given driveline gear ratios. Okay, so we will compare the different graphs, like which is considered in the case of internal combustion engine, and which is considered in the case of motor. Okay, so in selecting suitable power plant, the following factors are considered. Okay, so whenever we have to select any power plant, we have to consider these three parameters. Okay, so if you consider a prime mover, we have the internal combustion engine. Okay, so and we have an electric motor. When we combine these two, okay, so when we combine these two, we will have a hybrid. All you know already. Okay, and we have a single ignition, continuous combustion, in that spark ignition, diesel. Already you know all these things. Okay, and over here AC motors we are going to use AC motor as well as DC motor. So selecting suitable power plant on the operating performance. Okay, and second thing is the economy, and third thing will what, the environment friendliness. As we have seen from the last many of the lecture, so environment friendly कैसे रहना चाहिए, कैसे emission कम करना चाहिए. So that is the, it should be economic also. So for particular application, it is a like the ideal performance characteristic of power plant should be constant, our power output, so that overall full speed range the vehicle can run. Okay, also it depends on a torque, it depends on a speed. Okay, so what kind of drive you are using, okay, that is depends on the torque as well as speed of the vehicle. So if you see the vehicle power plant, actual vehicle power plant, how it shows, you can see over here. So this is the vehicle power plant, and so we are going to study the transmission characteristic of IC engine as well as the motor. So दोनों का हम लोग performance, so transmission characteristic we are going to study, मतलब with the help of graph. So with the help of graph, how exactly it is give the performance. So we know that this is a vehicle power plant. So here the torque and rotating speed from the output shaft of the power plant is transmitted to driven wheel through a clutch, or we can say a torque converter, as well as gearbox, uh, final drive, differential and drive shaft. Okay, here one thing, the clutch is used in a manual transmission. We know that already. It is used to couple and decouple what, the gearbox. Okay, couple and decouple out to the gearbox to the power plant. Okay, the torque converter is automatic transmission. Where we use torque converter? Torque converter is automatic transmission. Is a which device? Is a hydrodynamic device. Okay, that functioning as what, clutch in manual transmission with a continuous variable gear ratio. Okay, the function of gear box, which few gear ratios are there from its input shaft to its output shaft for the power plant, and torque speed profile to match the requirement of all the loads. So we use the gear ratios. Okay, and we will see what exactly the speed of and ideal performance characteristic of power plant. Okay, we will see that with the help of this uh, graph. Okay, so we know that ideal performance, when we see internal combustion engine can be used in vehicles based on two principle. One is a spark ignition, that is petrol engine, and second is a diesel principle. Okay, so the key features of IC engine based on ignition principle are high to power weight ratio, and a good performance, as well as the combustion noise. When you see the graph, okay, so this graph is indicated. So this is the ideal performance characteristic. Whatever this graph is indicated, this is the ideal performance characteristic for vehicle power plant. So you can see the two curves which has been shown in the figure. Okay, so one is for the torque and another is for the power plant. Okay, so here what happens? Initially, the speed is constant. You can see at lower speed the torque is low. Like first gear पे अपने को torque मिलता है क्या? Anybody? Any answers? Torque is,
Sir, can you repeat?
अरे torque अपने को कौन से gear में मिलता है vehicle में?
Sir, first gear.
First gear में मिल जाता है torque.
स्टार्टिंग में बहुत हाई होता है टॉर्क, फिर धीरे 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 कम हो जाता है.
Okay, so did you studied the performance characteristics of four, what we call it as, 1 minute, I'm going to tell you that. So this you have studied the curve. Sorry, torque is available. Okay, I have confused. Torque is available at a maximum torque is available at a first gear. So you can see with the help of this figure, you can how you can so compare the torque and power. Okay, कैसे compare करोगे torque and power दोनों? Whenever we compare both the figure over here, ideal performance characteristics of a power plant will ensure that maximum power is available at any vehicle speed. Okay, and it results in optimal vehicle performance. So torque obtained at a constant is at a lower speed. Okay, you can see it is constant at a lower speed. Again, it is reducing when the vehicle speed is higher. Okay, so you can see whenever at a zero, the power is increasing like this. Okay, and it goes a constant power at any vehicle speed. Vehicle speed Okay, as I said, it results in a optimal vehicle performance. Okay, the torque is constrained to be constant at lower speed, as I said now, and this is done so not to be a maximum limited adhesion between the tire ground and contact area. Adhesion area, so यहाँ से हम लोग adhesion area consider करते हैं, उसके नीचे ही हम लोग first gear, second gear, third gear, fourth gear we are considering like that. So with the help of this, you can see it looked like a so vehicle idle performance characteristic of power plant of any IC engine. Okay, so torque varies hyperbolically over here with respect to the speed. So you can see the curve, you can vary with the hyperbola. So when we compare with the torque as well as the power. Okay, so this is the one figure we have, and you can see the two typical characteristic of curve used to describe the engine characteristic are. One is the torque versus engine speed curve at a full load, that is 100% acceleration pedal position, and second one curve is second characteristic is the power versus engine speed curve at a full load. Uh, there are two curves, as one is a torque curve, one is a torque curve, and another is a the power curve. Okay, so it has been shown with the following nomenclature. Okay, so you can see Pmax is nothing but over here this term we can consider it as a maximum engine power, that is at a nominal or we call it as a nominal power. So P of T max, okay, you can see P of T max is a engine power at maximum torque. So engine power, so at a maximum torque we can consider this as, and Tmax. So Tmax over here, this can be considered as a maximum engine torque. So it is developed over here. You can see the intersection point is over here. So from here you can see maximum engine torque. So N next is a maximum engine torque. TP max. Okay, so this is a TP max. Okay, that is a engine maximum power at a nominal torque. Okay, so then NP max is nothing but engine speed at a maximum power or nominal speed. So P max, and NT max is a engine speed at a maximum torque. So over here it can be indicated with the help of two figures over here. Okay, so one is with help of maximum engine power, maximum engine torque. Okay, then maximum engine power, engine speed at a maximum power. Okay, so these can be considered. Okay, over here the higher value can be give a better engine speed. Okay, in terms of less frequent gear of changing. So today we will stop over here. Okay, so we will go tomorrow. We continuing this next thing. Okay, so we'll go with the electric motor comparison, torque and power. Okay, and this will be explained by tomorrow. This graph will be. Okay, we will stop over here. Okay, what is the strength of A and B C and D division? Total, how many people are took? This subject was active.
73 for C division, whole class.
Whole class has been taken.
Yeah, 73 students.
For D division,
No, sir. The class strength of C division is 76. Not all have taken this.
no, total I am asking the strength of both the division because the attendance is too less. Okay, I'm going to see how much is the attendance and we'll decide that. Okay. Okay, we will continue tomorrow. One thing I'm going to ask you that is it possible morning in the 8 o'clock
Yes, sir.
Yes, sir.
Yes,
for
sir.
all?
Yes, sir.
Yes, sir. Yes, sir.
so that
Yes,
we
sir.
can start our lecture early in the morning. So by 1:30, by 12:30, everybody is going to be free.
Yes, sir.
Okay, then we will have a tomorrow's lecture at 8 o'clock. Okay,
Yes, sir.
Yes, sir. Okay.
is it okay? Okay, okay, thank you. Just put your roll numbers on a chat box.